Hello, everybody! Welcome to the second week of the data science course by Machine Link Grads. Today, we're gonna talk about practical data transformation. I'm Adrian Spataru, data scientist at No Center, and I am joined by...
I'm Bogdan Andrusak. I'm data scientist at Kleine Zeitung. And I'm very glad to see you all on second week of our data science course.
So, today's agenda is the following. We're gonna talk about how to read data and how to clean your data. Then we will have a break and we're gonna talk about exploratory data analysis. The art of understanding your data, exploring it, and answering questions with it. So before we start, we want to talk about some organizational stuff. First thing first, it's about the grading. We had some question about the grading. 70% of the grading will be by the final project done in the last week. Then 20% of the grading is by the assignments, which we'll send you every week. And finally, 10% of the grade is given by the live quizzes we do during the session. Why 10%? Because nobody is paying you for doing quizzes. People pay you for doing projects. So that's why we focus more on the final project in the end. Also, Bogdan, what happens if people invite people into this course?
So for every new person you invite, you get 10 points. And then those people you invited, they invite other people, so you get even more points. So you can see that if you do it 3 times, you will have 100% of grading. So be socially active, invite your family, invite your friends, and make them all subscribe to our data science course.
Based on the grading, the top 3 people will receive a prize. What prizes they will receive, we will talk about that next week. Mm-hmm. For now, let's get ready and let's get set up. As last time, we're going to use again AHA Slides. So please, everybody, open AHA Slides. You can either join from your cell phone by going on ahaslides.com/week2 or open a new tab. That's also fine. Or alternatively, you can scan this QR code on the screen.
Maybe post in chat so we can so people can click in chat and see it in chat too.
And yes, it should be written now on the chat, ahaslides.com/week2. Gonna spam it several times. In case, so yeah, okay. So that's good.
We will remind when we will get to the quizzes.
Yes, so in case you have problems or people joining later, there's also possibility when the quizzes will just announce, hey, everybody join the AHA Slides quiz.
Yeah. We have more AHA Slides people than we have viewers.
we are so popular that Twitch can't keep up.
Exactly.
So what is before we actually gonna do anything, we asked you guys to get until today a Gmail account. And the reason why we need a Gmail account is because we're using a tool called Google Collaboratory. And Google Collaboratory is, in a sense, it's basically a place online where you can code. It's a IDE coding environment. So, and why we use Google Colab is because it runs also a thing called Jupyter, which is something which a lot of researchers and data scientists use. So what we're using here are state-of-the-art tools for programming in Python. Now, if you ever wonder what is this Jupyter, it stands for Julia, Python, T, I forgot, and R for R, the programming language loved by statisticians. So,
And we want you to use that because if you remember, we promised you that you will work with real data. So we prepared you a nice data set today from real source, and you will be able to follow with us, write your own code, do the transformations, and learn by doing.
Exactly. So that now we talked about what's Google Colab. It's time to open it up. So we have the following task. First, everybody open Google Colab. You can either just write Google Colab on your Google, it would just be first link, or just or the follow link on the screen. After that, so if you enter to Google Colab, you should see something like this. This is the first screen you should be seeing. So if you enter to Google Colab, this is the first screen you should be seeing. If you do not see this, then that means you maybe do not logged in your Google account, or B, you already experimented already with Google Colab previously. In that case, either way, you can just refresh, and if that doesn't help, just write on the chat. We can help you out with setting this up. So we're gonna take our time really to everybody get on the same page. So don't worry, everybody has opportunity today to work on code today. Now, if you manage to open it up, there's only 2 more tasks we have to do. One thing, we have to press here on the GitHub tab. And after here, you write here in the search bar, AI grats. That is AI grats together. And if you press enter, you would see exactly this file over here. Now, if you have any difficulties, write in the chat or write in AHA slides as a question, and we're gonna help you out. So the task is to open GitHub tab, write AI grats in the search bar, and then after that, double click on the week 2 IPython notebook. So I see already somebody wrote a question, I think. What chat are you talking about? It is somewhere on Twitch. Exactly. So on Twitch, you can write there in the comments, or you can write here in the AHA slides as you wrote, Mr. OS Dev. So that is the chat, the Twitch chat. But the only way to comment on the Twitch is that you have an account on Twitch. But don't worry, if you still are experiencing issues, you can just raise it as a question on AHA slides and we'll help you. So this is what you have to do. Go to Google Colab. Once you open Google Colab, you press on GitHub. You write AI grats here. And then you press week 2 IPython notebook. So if you double click on this, you should see exactly this. And after you see this, you should press the connect button. So the connect button is on top right. And what the connect button does is opening a server where we can run our code. So this will open in Google Cloud, a server, and this should work. So if you press this, it will try to connect. And after connection, it will say it will be connected. So now it's initializing. And finally, it is connected. And if you see RAM and disk, that's perfectly, you're ready to go for today. So if you didn't manage to do this, write a question, tell your issue. We will gladly help you out. So we want everybody to have a nice learning experience today. So I got I saw a question now on Twitch. Where can I find the GitHub button? So if you open, let me just open it again. Let's do it like this again. Google Colab. So the GitHub button, once you open it, this window should appear. If you see this window, you press on GitHub. This is where you find the GitHub button. And once you clicked it here, you can write here AI Grats dot just AI Grats, sorry. Press enter. And here you see week 2. And if you double click on it, then you're ready to go. One more time. So we'll show it one more time for you guys. So as mentioned, you go to, you write Google. Give me a second. It seems like my email browser is open. Let me just kill it. Thunderbird. Okay. So we go on Google Colab. You can just put that in your Google. Open it. Once you open Google Colab, you press here on GitHub. You write here AI Grats. Press enter. And then finally you double click on the week 2 IPython notebook. Okay. So if it's working, give a like on AHA Slides if you managed to connect. If you just entered now on the stream and you like what is going on, please follow the following commands. And if you want to press your heart to show us that it was working for you guys, write ahaslides.com/week2. So this one you can open in your phone or in your browser. It's ahaslides.com/week2, and give us a heart on AHA Slides to tell us that it's working for you. So 39 people already confirmed that it's working for them. 40. So if we get around 50 people, then I think we will start. So for those who just came, I will demonstrate one more time.
No, we didn't have the change of views. I think we can move forward.
Okay, good. So I guess we can continue, I guess, now.
Yes.
Okay. So, okay, there's a poll anyway. Once more, just to be confirmed, so we can see if somebody is not working. So answer the poll, is Google Colab working for you? And now this should clarify the situation. Okay. Seems like we're just getting guesses. I think it's time to start.
Yeah.
So, what data are we working on today?
So we are working on data regarding money. So it's a adult census income from USA, and this is so census is when the statisticians employed by government go from house to house and ask people different questions and make statistic on it. So this one is about if people have more than $50,000 income per year or less. So it doesn't say exact amount of income, but more than 50 or less than 50. There's some other the whole data, you will be able to see it when you will load it, and then we will talk about each column. But yeah, now we can go into it and learn actually how to load it. So from last time, you remember that data is collection of different facts, and this data can be stored in so many formats that it's very hard to take them all in account. So there is, of course, the common types that everybody of us saw in our usual work, but there is also types that are used for very specific domains. For example, medical data stored in different formats than, let's say, engineering data. Of course, they can use Excel stuff, but usually they have different files. And if we can look on what is the most common, on my opinion, on the next slide, I think the most common is a CSV format, so-called comma-separated values. Then you have your Excel files, plain text, JSON, HTML, SQL, images. If you work in computer vision, you work with images, and there's a lot of different image formats. And the same with music. If you work with sound, you probably know that there is a lot of different formats. Today, we won't be able to focus on all the type of data. So we will focus on what is called a spreadsheet format of data. In other words, table data. So I think you remember from last time we had this little table of apartments and apartment prices, and it's very easy to understand. We have the data organized in row and columns, and the actual value of data is stored in cells. So very, very easy to understand and very intuitive. And the spreadsheet format can be stored in many different ways. So most commons on are CSV, so comma separated value, Excel files, and JSON files, and sometimes HTML. But I would say CSV, Excel, and JSON is the most common. And we will look into how to read all these data formats because they are different. But what can help us? Pandas and Python. So maybe if you are coming from a computer science background, you know that I'm not talking about a snake and a bear. I'm talking about programming language Python and library Pandas. So Pandas is very powerful library for working with data, specifically with data that is in a spreadsheet format, and it has a lot of tools. And yeah, I would say 80% of functionality you would ever need is already in Pandas, and it's continue growing. It's open source, and they already had release version, so they are not in testing anymore. So now let's talk about comma separated value file format. It's very easy. It's values separated by comma written in rows, and there's nothing really specific about it. The one thing that sometimes it's separated not by comma but some other delimiters, especially if, for example, if you convert Excel file to CSV, the separator would be semicolon and not a comma. And sometimes it's a tabular sign, or it can be cases where it's hashtag or even some other bizarre separator. You need to take it in mind, but you always can open it in your notepad and look at it, how it's done. So in Pandas, it's very easy to read it. So well, first we of course import Pandas, our library, and then we create a data frame. So our tables in Pandas, they are called data frames, and usually we name them df. If But you can make more meaningful names, and you should not call all your variables df1, df2, df3, at least more meaningful. And we just say pandas read csv and provide path to the file. And in this case we can specify a separator. So by default it's always comma, but if you would know that it's a semicolon, here we would put a semicolon. So as you see, it's very easy. So next format is Excel file. So it's a file format developed by Microsoft based on XML file format, and it's very similar to CSV file. The main difference is that in Excel you can work in one file with multiple sheets, and you can switch between them. So when you are reading it in Pandas, you cannot read all Excel file in one table, because there is it can be that there is multiple sheets. So every sheet is saved in one data frame. So here we need to specify which sheet we are reading. So in this case, it's sheet number 1. And the other things is similar. We just says that it's a read Excel and not read CSV. So nothing hard here. Next one is JSON file format, or JavaScript object notation, and it's used for most commonly for transferring data through the internet. So if you working with some API online, it will always, I think, always return you JSON file, and it's less readable for human understanding, and but you still can look at it and quite read it, or at least get a feeling what it is. Especially if you open it in a web browser, it will nicely structure it. But for pandas are very good with it. You just say read JSON and you get same data frame if it would be stored in other format. And you can everything what you read, you can write. So for example, if your data was in JSON and you feel more comfortable with working having data in CSV, you can read JSON and save it as CSV through pandas. It's very easy. So this is this is just a few of the formats that pandas support. Here's the complete table. I think you get general feelings that you just need to call the right function and provide a path to the file. And yes, here's a complete list. And if you will practice data science sooner or later, you will meet them. So now check all these read functions, and we will go to the first practice and first quiz.
Yes.
So you will have to write you will have to load the data that we prepared for you.
Yes. So as instruction for the current quiz, I would like you to press on the load libraries and data. And what I want you now to do is from here, press the first line of code, and you can either press Shift Enter or press this button over here. I would recommend you should get in the mood of pressing Control Enter or Shift Enter. And what this first line of code does, you say run it anyway when this error appears. So what this error says is like, this is some data not from Google. Don't worry, this is not a virus. This is directly a CSV file located on our server. And here we can see we're downloading this command. We just downloads this file from the internet. And after, it should take several seconds to download. And yeah. So for the next line of code, again, you press Shift Enter. And what happens is that this is basically importing the libraries Pandas and NumPy. Now, if you just came now very late, you go on Google Colab, you press, once you open Google Colab, you press on GitHub, and after on GitHub, you write AI Grats here, AI Grats. And after writing AI Grats, you just double click on week 2, and then you have the same thing what we are doing for those people who just wrote they arrived late. So now back to the here. Now this is the actual quiz. So what I want you to do is to save in this line of code here. I want you to load the data, and I want you to load it in a variable called data frame, df. So as we previously showed, we already wrote you the command in the tip. So I want you to write this, and the path of this data is exactly here, as written here.
And it's comma separated.
It's comma separated, yes. And after running that line of code, run the second code, which allows you to answer the quiz. The quiz is, how many rows and columns does this data set have? And what this df shape will give you the number of columns and rows. So we will give you now 1 minute time, and then we're going to run the quiz. So after you run the previously first 2 commands, this should work. Okay. So I'm going to start the timer right now. Okay. So I see more people who joined later. Don't forget to, after doing the notebook and calculate your answer, if you want to submit it, go on ahaslides.com/week2. That is ahaslides.com week2. I will write it in the chat in case you don't have this, to join the quiz. Now for this first quiz, we're not going to wait anymore. But if you want to join for the other ones, please do so. Okay. So we'll start the quiz right now. Okay. So let's see how well you did, guys.
Yeah, so if you see that there is the timer that you have on your quiz on your phone and timer on stream is different, it's because latency between the stream and slides.
Yes. So take into account when we see already we're going to start the quiz, most likely it has started on your phone. And seems like everybody who put their answer in actually got the correct answer. And that's very good. Very, very good.
Yeah. But still, we will show the solution for people that didn't participate.
Mm-hmm.
And we also have to fill the code because we will show the more stuff. So we need to also write our notebook.
Correct. So the command is df, data, which stands for data from, equals to pandas, which is written as pd, read.csv. So the command as written there, and as path we wrote in quotes adult underscore rev2.csv. And this should run. And if we run then the second line of code by pressing shift enter twice, we can see here 32,000 rows and 50 columns. Now, if you want to...
I think we can talk more about data. So
okay.
Show, yeah. Now we can look on the columns. So if you write df.head.
Yes, so df.head loads you the data. More specifically, it shows you the first 5 rows of the data. So should we go through the columns and the values?
Yes, of course. Yeah. So first you have a social number. So that's like a personal ID of the person. And then we have age, quite understandable. That's how old person is. Work class. So work class is in what sectors they work. Is it a private sector? Are they self-employed, or are they working for government?
The values with
Education.
none, the values with none just mean empty values, which we will talk about later.
Education is education level of the person. So is it high school, college, or they didn't finish high school and stuff like that. And education underscore num is years of education. Marital status, it's a status of marriage. Are they divorced, separated, widowed, or never married? Occupation is their work. So, for example, executive manager, machine, prof specialty, and others. So we will look at it more in details later. Relationship is more, do they have kids or are they married? So that's like a little bit connected to marital status, but not completely. Race is it's a race, sex, female, male in this case only. Capital gain. So capital gain and capital loss is quite interesting. So capital is assets that you own. For example, if you own your house, it's a capital, and it's not related to your salary. And if you gain something, your capital gain increase in this year, and if you lose something, you have a capital loss. Again, it's not same as salary. And next one is hours per week, how many hours people work, native country, and then it's income, less than 50,000 or more than 50,000. So that's the data that we have today, and we will work on it. You will be able to transform it and analyze it.
And we can see here the notebook, it's written about the topic data cleaning. Now for that, oh, what happened here? Interesting. Technical break. There's somehow a quiz started here. I guess the quiz hasn't started, or it started, but yeah. So we'll run one more time the quiz in case you had your answer. This is the only rare opportunity you get the second chance to put your answer in. For those who put already your answers, that's not a problem anymore. But here you have this amazing opportunity for those who just came late or were not so fast with the fingers to put in their answers.
So we want to see 70 answers. So now there's no excuses.
And yeah, some more people managed to put some more answers in, and that's really good. Okay. So back to the topic, data cleaning. This leads us to an interesting phrase, Bogdan, right? Garbage in,
Yeah.
garbage out.
Yes, because in order to clean something, you need to understand what is garbage. And the phrase garbage in, garbage out, or how the hype data scientists say GICO, because everything should be an abbreviation, means that if you have bad data, you will have bad results. And it's always, you cannot have good results with bad data. And here on next slides, we will explain more what is garbage. So here, before we start talking about garbage, let's look on an example from previous week when we talk about predicting the prices of the apartments. And this is the case of relatively good data. So we could do some linear predictions. But also, we showed you what happens if we don't have enough data. We get bad results. So that's what it means. Garbage in, garbage out. You give us garbage data, you get garbage results. And there is a lot of problems that your data can have. I decided to focus on these files as they are more common to all data sets, independent from the application, and usually happens all the time, because some industry specific, they have different problems. So first are duplicates, missing data, incorrect data, inconsistent formats, and insecure data. So we will start talking about duplicates, and how name suggests the data is duplicated. And here is the example is simple. Every row is duplicated. It's very important to understand, is it possible for your data to be duplicated, or every row should be unique? So for this case, it would be possible maybe to have exactly same input, because it's possible to have same apartments with same price, but here we see that the duplication is so regular that maybe it's the faulty of the system. And with pandas we can easily get rid of it. So if we say df.drop duplicates, it will remove all duplicates. But it's important to understand that in pandas, when you do such transformation on data frame, it's not changing your data frame, it's creating a new data frame. So you have to write df equals df drop duplicates to save your results because if you don't write it, it just show you how it would look without duplicates.
So now we learned this new command, df.duplicates, and it's time to implement. And if you go here on the notebook, we see this big topic here, data cleaning. If you press on it, it should expand, and we can see the first assignment here is to drop the duplicates in the data. And as Bogdan mentioned, it's very important that you replace the current data frame with the data frame which has no duplicates anymore. So I will give you a hint now for this assignment, because I'm very nice to you today. And we're gonna write data frame equal, and the rest is your assignment. And after you did this, after you drop the duplicates, to really know if you really dropped them, we want you again to tell us how many rows are there left after dropping them. And please keep note, you learned this command already, so if you scroll up, df.shape, you can use the same command to actually extract the number of rows. So again, we will give you 1 minute. The command, if you forgot, it is df.drop_duplicates. Yeah, I wish you good luck, and we will give you exactly 1 minute.
In the meantime, we can check if there's questions.
So if you came late to the stream, you just arrived and you see, okay, good, I want to do the assignments, no problem. For that, you have to go to Google Colab on the website. And if you Google it, this should be the first link. After pressing it, you enter. You press then on GitHub. And after pressing GitHub, you write AI Grats. After writing AI Grats, you press enter, and you see here a file called week2. You double click on that and you can join.
Yeah. And then you just press connect and run the cells till we are working. So you will see in the code later.
Okay, 10 seconds left. I hope you almost done. we will show the in case you didn't manage to do it, we will again show the solution. So we're gonna start the quiz now, and let's see how well you did. And time's up. So let's see how well, and most people actually got it right. So some people got the error, not error, they got the same size as previously, and
Probably they didn't save the data frame.
Exactly. So that's why very important. You have to write the following: df equals df drop underscore duplicates. And if you run this, this should look fine. So if you write df.shape, we should get 3,589. A cool trick is that this is a array, so that means we can access it like this by with adding a bracket. If you write 0, this will just show us the first value. If you want to get the number of columns, you would write, for example, then here 1. So this is a thing you can do in the future. Okay, let's go back let's talk about missing data, Bogdan.
Yeah, so missing data is a huge problem, huge, because we have incomplete data. We can have, a lot of rows, but you see that like in a half cases the price is missing, and it makes our data complete trash. And there is a lot of different reasons why data can be missing. The most common is, the sensor was broken, or the person that was collecting data was lazy and they didn't write everything. But or when the data was transferred from your customer to you, there was the files got corrupted and some of data got missing. Sometimes the data is missing by default. So for example, if it can be that if the question is how many kids you have, and you are less than 10, people won't ask you this question. They will just make the data missing. So you need to understand when the data is missing because there's error. You need to understand where the data is missing because by design, and and that's from case to case, specific from case to case. And but you need to always remember to check before you start doing anything. Check if there's duplicates, check if there is missing data, and then start continue asking questions.
So we got a question from the audience. Peter S asked, when I run dataframe.shape function, I got an error. So for that, you didn't load the data. So here's the code. You have to load the data first here, writing pd.csv. I have to define it here because you have to load it first. If you came late, I will just look now. I will show only the last time today because we have to continue with the course. But don't worry, they will be recorded afterwards, and we also will provide the final solution after this course. After tomorrow, you will get the complete solution of everything what we did today. So you load it like this with this command, and then normally you should not get an error anymore. Okay.
So I think now when you are familiar with all of this, I can say that you are halfway to data science. And we can check it, actually. I believe, Adrian, can we check if our...
Yes, and I'm gonna start the music. Welcome. Are you a data hacker? Well, we got the ultimate challenge for you. In this competition, you in the competition of the Count Master, we can show what you really are up to. The game are simple. Count how many triangles you see
in each slide.
So, yeah, this is a game, interactive game, and you have to count how many triangles are there in the image. And for that, we will do a test round so you understand what do we mean with counting triangles. So, we will show you a lot of slides, and you have to count the number of triangles. So get a pen of paper. I think the best way to do this is take a pen of paper, and every time you see a slide, write the number of triangles down. So here we have 2 triangles. We write that down. And on the second slide here, we see we have 3. So we write that down. And then at the end, we sum everything up together. So in this case, it's 5.
Yeah. And you will have a nice table, nice spreadsheet where you will have slide 1, 3 triangles, slide 2, 2 triangles, and you will be so that's a data collection challenge, a hackathon.
Yeah, so you can show us if you're really a data hacker and if you're truly a count master. So I think it's time to get ready. Get your pen and pens ready, and we're gonna start right now. So get your pen and paper. Give me a second. I need to set up here something up. We'll start anytime soon. Okay. Get ready, guys. There will be 10 slides. Okay. Be very fast. We won't go so slow. So good luck. The music. 3, 2, 1, go! Completed. Okay. So at the end, it was a bit fast for you guys, maybe.
Not.
Let's see if you're a true count master. This should be easy peasy for you. So let's see how well you did. So we'll give you a bit of time to calculate your sum. To sum up the numbers. And let's see how well you did. If you just joined now, you go to alphaslides.com/week2 where you can participate to the quiz. Yeah, so I think that was very, very intense. And I don't know, Bogdan, it seemed a bit too easy for us, right?
Yes, I think it. But yeah, that's always the first question in data.
Okay. I know it takes a time to calculate down. I know it takes there were a lot of slides, so I understand if it takes longer, especially if you calculate by hand. It's fine. If you're using a calculator, that's better. Then you should.
Well, you can use a notebook provided to use it as a calculator.
Yes, it's good time now to practice your Python note skills.
But yeah, I think we can start the quiz.
Yeah, I think we can start it right.
A few more seconds to.
Okay, last 10 seconds, I think, and then let's see how well you did. If you're truly a count master. Okay, let's see how many of you are true count masters. Quiz starts right now. Okay, time's up. Let's see how many count masters we have. An incredible 32 people who are true count masters. Incredible.
So nice. You see, there is a lot of potential here.
I see, yeah. But we have 2 more questions actually, Bogdan, right?
Yes. So that's as a customer, when I give you data, I want to know everything about it. So my next question, like I give you my data, and I want you answered my first question, but the second question, how many triangles are?
Squares.
Hmm?
How many squares are there?
Yeah. How many squares are there? You have the data. You already saw the data. Please tell me that.
So again, we let you to count. I guess you have to count. Some of you surely, as true data scientists, prepared ahead of time. You have all the data, right, Bogdan? They have all the data.
Yeah, the
There's no
data
excuse.
was there. The data was there. So please now, how many squares?
Yeah, so calculate that up. Of course, I think they need a little time, to calculate, because
To count
surely,
it.
yeah, to count it. Okay. I put just 20 seconds, and then let's see how many true count masters we have. Okay, let's see. So, question number 4. How many squares did you saw? Okay, time's up. So let's see. And that we got answer all around the board. Some people very close, but only to 10 true count masters.
Or just lucky.
Or just lucky, yeah. It's a 25% chance.
Mm-hmm.
Okay, but one more question. We have one more question for those true count masters. How many circles, right, Bogdan? How many circles?
Yes.
Because your clients are not going to ask you what are my triangles and not square. They will always have that one extra request. One more question. That one more question, which is very hard to answer.
So as I see, majority say that there was no circles at all. But as a client, I am very sure that there are circles in my data.
Should we show them?
I think we get that majority for 0. There is some people that believe that there is 1 or 4.
Okay, let's see. Let's see what is the truth. So let's go to back level 1. There was a circle here. So here's level 1 we showed you. 2 triangles and 2 rectangles. And here, there's a circle. It was a white circle behind a white behind a white square.
Yeah, you should have seen that as data scientist. I knew it. As a customer, I knew it. It was there. So that's a little taste for you how it can be when you work on real projects. You think that it's only squares and triangles, but sometimes there's the circles that nobody expected, and you need to take it into consideration.
And before we continue, let's go through the leaderboard. So I think first place we've got Dr. Evil, followed by Arno, Libby, Rick Jarzy, Zoo, Anti, and our last week winner, actually, Max. So, definitely a lot of top potential here. So why were we talking about this?
Yes. So because missing data makes your data is garbage. So first you need to so what actually we did, what was the technique that where you were counting the sum of triangles is called checksum. So when I'm like if I have a data and I want to give it to Adrian, in order to see if there was no corruption in the files, we do checksum. So for example, I sum the all values for the amount of rooms, and if he has same value and I have same value, there is high probability that there was no corruption and data is correct. And so that's one way to check it, if there is something disappeared from data. Other way is to count the amount of missing values. So it's very easy, especially if your missing values are really missing. You write df, and you can. So now we are checking inside the column, not just in whole data set for each column. So we write df dot price. It means that we are looking on the column price, and to check how many non values, we write give me the values of is none, so the values that are none, and sum their amount. So very easy, one line, and we see the output is 2.
And I think it's time to see if
Yes.
they can answer our questions with this, right?
Yeah, so immediately apply the knowledge on the data set. And you remember that we had a work class in
Yes.
work.
Mm,
Yeah.
mm, um, but before that, I think we should maybe show also the one more command, which is
Yeah.
removing missing data, maybe.
Yeah, exactly. Yeah. So, like, why just knowing the number of missing values doesn't really help us. We need to get rid of them. So in pandas, this is the easiest way to deal with missing values, just to completely remove them, and you can do it by drop none, same as drop duplicates. Just drop none values, and it will remove all the rows where is at least one non value is present.
Okay. So first, I think quiz.
Yeah.
1 second.
Yeah, so the first question would be how many non-values we have in a work class, and then
Yes.
you will have to
Mhm.
remove it.
So first quiz for now is how calculate how many values are there missing in the column work class.
Yes.
So the column work class, we can show you. If you're not sure what columns are there in the data, you can always scroll up to the df head. But another trick we can then teach you guys is df.columns. And if you run this line of code, it will list you all the possible columns in a condensed way. So you can see here, the column is called work class. So your command should be something like df.work class. Now that's enough help. I hope you paid attention, and I think now we give you a 1-minute timer.
Yeah. So maybe 2 minutes, because after you count it, next question is already you need to remove those all the missing values and tell us how many rows left after the non-values were deleted. So please answer the next 2 questions.
Yes. For that, don't forget here you have to replace your current data frame. So you write here df equal and whatever the answer might be. So these are the um, two tips we're going to give you for now. Okay, so I've showed also. I flashed a bit the previous slides in case people didn't saw. So, but now
But
I think
nobody was watching. Everybody was coding.
yes, of course, I think. So let's see how well you performed. So the first question: how many values are there missing in the column work class? Okay, 3, 2, 1. Time's up. And almost everybody got it right. Wow, excellent, excellent. So let's see how well you did for the second question. So the second question: how many were there after removing them? So the number of rows. Let's see how well you did there. Okay, and time's up. And again, almost everybody got it right. That's excellent. So let me show you the solution in case for those who didn't manage to type in the answers. So so the first question was, how many values are there missing in the column work class? You write df.work class as written here. Then isna, which returns the values which are empty, and we sum them together. And this gives you 1832. And for the second question, we had to write df drop na. And if we would look at the number of rows, we can see we have 30,189 rows left. Okay. So missing data is one of the topics, but there are also other type of problems, right, Bogdan?
Yes. So next on the list is incorrect data, and that one is I think the hardest to check, because if the data is incorrect and you cannot obviously understand that it's incorrect, then you will think that it's correct. For example, here it's quite easy to get that probably data is incorrect when you have amount of rooms less than 5 and the price is less than 1 and the street name is not a name but some set of numbers. Then you see as a set that the data is incorrect. But if you have, let's say, a reading from sensors, from many different sensors, and for example, there is temperature sensors that shows you 100 degrees. You don't know, is it because it's really hot there or maybe not. That's why data scientists had to be data domain expert. You need to understand the data from domain so you can see what is correct and what is incorrect. And here, like, you have to use your common knowledge, common sense, and you have to ask people that give you this data. Don't be afraid to clarify with people. Is it possible? Is it all right? Does it look all right? Because the time you will take to ask those people questions will save you much more time in future and prevent from big mistakes. And the mistakes with incorrect data happens every time and every day at the companies that work with data. Nobody is safe from there. So just don't be afraid to ask people about the quality of data and the meaning of data. Don't be shy. So that's, and there's no easy way to, you cannot write panda incorrect data. It's not that good yet.
But maybe in the future, with the development
Maybe in
of
the
AI,
future.
we
Maybe
could,
in the future.
yeah, we could have something like that. But this is something maybe within 10 years far reach.
Yeah. Slightly less problem, but very annoying, is inconsistent formats. It's when you have data, correct data written in different formats. For example, in this price, in this case, the column price is, you see one numbers are written like numbers, some written like string with euro, some strings have big euro, small euro, euro sign, and it's very annoying. So we need to to make it one format. And again, there is no easy way to do it. You just have to write a code, write on which format you're going to use, and make the transformations. And so you've been already doing some exercises. Now you can look how Adrian would deal with the inconsistent data in our data set. So, but not don't just look. Please write the commands with him, so we have the same data frame together.
Yes. So everything I'm gonna write here. I would want you to write with me, so we can deal with this inconsistent data. So why do we have inconsistent data? Let's see. So let's check the column called income, and here's already a line of code already written here. This is df.income, so the column income value counts, and value counts returns me the number of values of every so it will extract every unique value, and it will tell you how often that occurs. So we can see here that we have smaller equal than 50k, bigger 50k, but we have that's also written in a different way, like actually spelled out less than 50k, more than 50k. And finally, we also have this one case over 50k, which is the same thing as more than 50k. So to do this, we will learn some new Python operations. So one of the question is, how can I get from a column the from a column is a certain value? So I want to return me the data from where the value of income is equal to a certain value. So in this case, let's say I want to get all values. So I write data frame first, and I open bracket. And brackets are used for doing queries in pandas. So we write df again income, because we want to get a certain value from the income column. Then we write equal, double equal, because we are comparing here strings, which will, in case you're not familiar with those, don't worry, we will follow out on that later. And here, in quotes, we write less than 50k. And if I would run this, I would get all the rows where the income where the value of the income column is less than 50k. Okay, so we've got that. Now let's see how we can use this to fix it. So let's make a decision. We have so many ways of writing it, and we have to determine what way would we like to have it. We need to find a consistent setting. So I would suggest that we would do it only like this. So smaller equal 50k and bigger than 50k. Why? Because it's just shorter to write, and yeah, you don't want to write all the time sentences in when you want to query your data. So I think this is the most pragmatic approach. To do this, we will save the indexes all of our three values. So in this case, we wrote df income equals less than 50k. To get the indexes of those rows, we write that index. And this returns all the index values where that row occurs in our data. So we will write here, we will save this in a variable called less than, which we will process later. So if I run this line of code, it will save it in a variable, so now output. And if you write just less than, it should return exactly what we previously stored. Okay, So to actually change that value, we will use a new command called lock. So df.lock, what it does, it gives me all values from a certain index. So if I would pass indexes index 0, it will return me the value, the first row. In our case, we already have some indexes which are less than 50k. So we save that in our previously stored variable less that. So we write it here, and then we write a comma, and here in quotes we write income. And what this does is that before this would determine what column do you want from that row, and in this case we want all the values from that column which has less than 50k, and replace it with another notation. So if I run this, you should get less than 50k, less than 50k. And now, if you want to replace that value, you just write equal, and with the value you want to replace. So in our case, we want to write smaller equal 50k. Note that I write big K, because that's how it was defined above here. As you can see, this is a big K. So be very careful when you do the exercise with us. Write it this way so you won't have any problem. And if I press Shift Enter, it's done. It's done exactly what I wanted. So if I run again value counts, so if I go to the above row, if I run it, we can see it's gone. It's still, and because we replaced it with smaller equal 50k. Now we have two more values to deal with. So let's do that. So we can do this a bit more easier with a command called isIn. So to query the data, we write df, again in brackets for our command. We write .income, and we write isIn. And what this command says is that you pass an array of values, and in that array of values, it would look if it's in income. So in our case, we have two more values we want to compare with. We have more than 50k, this one over here, and over 50k. Okay? So if I run this, I will get all the data where the income value is more than 50k or over than 50k. And then we can do the same thing as we previously did with the index, save the index, and then write the lock function, which we defined here previously, and write it again as previously. So in this case, we're gonna get the indexes as before, so .index at the end, and we're gonna save it in a variable called more than. And this, if it's done correctly, if you would write then more than, that, we could see we get exactly the indexes what we previously mentioned. And now let's fix now the rows. We write df.lock more than, and we will get the income column again, and we write here bigger 50k. Note again, I wrote big K as it's here defined in the top. So exactly like this. And if you run this, it should be fixed. So if we go back now to the top, value counts, we should only get two different unique values. Smaller equal 50k or bigger 50k. So this is the data, this is what you should write down in case you were a bit slow. Hopefully now you have opportunity to pick up the pace. And this should work. And if you got this, we can actually continue with the next quiz. So before we're going to consider with the next quiz, we would like to answer some questions. So let's see what questions are there. Are there any questions, Bogdan? We should talk.
Fixed. Okay, the one is fixed. So somebody is getting this. It's I think it's common. A value is trying to be set on copy of slice. Yeah, so it's a warning. And I believe Webmax you are using. Are you using Google Colab or are you writing it you in Jupyter?
Yes. So it should be exactly what. Yeah.
Uh,
So people, okay, let's see, let's go through. So hey, if I want to run the function, df okay, this value can't. Okay, good. This is cleared. Stefan asked short break. Yeah, we could do a 5 minute
Yeah,
break.
actually, it's coming in a few slides. So we are gonna address insecure data, and then we will have a break. So a few minutes.
Okay, for a few minutes. Okay. I got different amount of rows left. This is most likely that you didn't set the data frame previously. Maybe during the break I will show it. You can copy the code if needed.
Mhm.
I think the green and white. Okay, so most of the questions are not when I run. Okay, good. So these are this was answered previously.
Mhm.
Okay, good. So insecure data. Let's finish up. Let's get the people they want to break soon. Let's talk about insecure data.
Yeah. So insecure data is quite new occurrence in data quality. It started when the different countries started to introduce data regulations laws, which lead to huge fines to the companies if they use personal data or if they don't secure their data. According to GDPR, if you from European Union or if you working in European Union, you have to have your data according this law. You cannot have personal data, and there is quite good. There is you need to read how it's defined in law. For example, what consider personal data is people's religion, people medical history, previous. Yeah, medical history, imprisonment history, anything that can identify them, for example, like social passport numbers. Uh, yeah, this kind of addresses. This is personal data, and you should not use it. And if you leak this data, if somebody hacks your company and you get this data out, you can get the company get fined in millions, and potentially it can bankrupt the whole company. And well, as data scientist, you are responsible actually for what is happening in data. And if you see that data, you have personal data in your data set that shouldn't be there, you should first of all notify your managers and responsible for project. And then from you should have your integrity and not work with the data that is too personal. And because you need to keep your ethics and don't do evil solutions. So when you see something that personal data, one of the ways is you can encode it if you still need to use those features. If you don't need those features, for example, like here in this data set, let's say we have like apartment data about apartments, and somehow we get a religion of owner, and that's the feature that shouldn't be used in any it's not. It's like religion of owner doesn't influence price in any way. And any like speculations are just based on prejudice and are not scientific, and we don't want to include it in our machine learning solution. So in this case, we will just delete the whole column and forget that we ever had it. And it's quite easy to delete columns in pandas. We just use the command drop. And in labels, you write the column you want to drop. You can write multiple column. And very important, it is to specify axis. So because with drop, you can delete rows and you can delete columns. So if axis is set to 0, it deletes a row based on index. And if axis set on 1, it deletes a column based on the name of column. You can delete multiple labels, multiple columns at once. So then you will have to pass to labels array of names. And again, it doesn't change your data set, it creates new ones. So if you want to those changes come in place, you need to replace your data set with new one, as in previous cases.
Yes. And if you don't know now to the quiz, so now you have to drop the social number column in our data set, because we don't need that information to predict maybe the income. So for
And
that
it's
we have,
very insecure.
and it's very, yeah, exactly. And for that, if you don't know the column name is social underscore number. Okay, you can always check that with the commands which I told you. df.columns. Here you can see how it's called. So you have to drop it, and then the quiz is how many columns are there left. So we will give you exactly 1 minute. So we're gonna then we go to a break, and we're gonna talk about that in a second. So let's go to the quiz, and let's do it. Starting right now. Okay. So let's see how well you did. We're gonna start, I think, the quiz right now. So hopefully you managed to get that answer on time. So the question was, drop the social number column, and after that, how many columns are there left? Okay, time's up. Let's see how you did. And almost everybody got it right. And some people answered 3,000. That is not the question. Was not rows, but how many columns there were. So the solution was the following. Let's switch to the notebook, and it's df equals df.drop. Here in our case, it's social number. And we define axis 1 because it's a column. And then we write the df.shape, and we get the number of columns, which is the second, 14. Okay. Let's look one more time in the leaderboard. We've got first place Arno, followed by Max, the champion from last week, followed by Zu, a newcomer, Dr. Evil, Robert, Sebi, and the D. So,
but everybody is very close to each other.
Yes, if we can scroll a bit down, you can see, wow, everybody, it's a very, very, very tight fight for the leaderboard. So I think one more, let's talk about this, data types.
Short. So really short. So you see that data can be in different formats, and pandas can handle all of them. So the most common are floats. It's numbers with floating point. Int, integers, datetime, which is responsible for datetime. Time delta, which is responsible for amount of hours, days, years, and others. And strings, they are for strings. And boolean values for true and false. Panda has much more and more complicated data types. If you are interested, you should check on their documentation. There is such intervals and categorical data, and they are very optimized, especially when you are starting working with big data. You really need to think what types to use, because it's if you store a boolean like an integer, you use a lot of extra space.
Okay.
But about that we will talk in future, and now we can take a break.
Yes. There's some. Let's see some questions. I think. Let's see. Last moment. I got an error. More that. Okay. Some. In your case, Mr. Polar, you forgot the round bracket around the end. So this is what is missing. That's why it's got unexpected error. So you put here the round bracket and then a square bracket again here, round bracket, square bracket, as mentioned, and it should be solved. I will show while in the break. I will show it. Show through the break. Maybe I scroll one more time if you want to copy the code. Okay. Nothing else seems to talking about the current problem. So I think as a teaser, exploratory data analysis, and this we will take after the break. We're gonna take a 10-minute break. One more question was, can you approximate when will this lecture be done? We expect that we should be at 7:30 done. So that's what we are planning for now. Hopefully we'll also manage to do that. But for now, we will take exactly a 10-minute break. Stretch. Take a glass of water. Go outside, get some fresh air out of your balcony, of course, because we are all in quarantine. And yes, see you in exactly 10 minutes. Welcome back. I hope everybody's energized, you feel fresh, and maybe for some of you, what is a bit too quick, maybe too slow. Um, we will increase the space now, the pace up now a bit. We will be a bit more faster, but now we're gonna learn very interesting stuff, and something which is something very close to my heart, and that is exploratory data analysis. Now, exploratory data analysis, or short form exploratory ADA, is basically cleaning your data, summarizing your data, and finding patterns in your data. Or, if you want to remember one sentence about EDA, it's about telling a story with your data. So, why would you do EDA? Well, it helps you understand the quality of your data. As Bogdan mentioned before the break, with inconsistent data or with insecure data, you need to understand. By looking at the data, you can find like inconsistencies, but if you never look at it, you can never identify those things. For example, you can gain quick insights about your data, and finally, finding potential patterns. Why do you care about patterns? If you want to predict something, you need to find patterns which can help you predict those things. And for this, we can use a tool called descriptive statistics. Now, if you see the word statistics, don't worry, it will be fine. You will see descriptive statistics, you will fall in love with it. It's one of those statistics which you will actually like. And this descriptive statistics is the art of describing basic properties of your data, and in essence is the basis of all quantitative analysis you will ever do on your data. And in this section, we're going to explore different techniques, how we can do that in our data. And the first type of analysis is univariate analysis. And univariate analysis means analyzing one single variable, one single column in our case. So if I would have, for example, this column with salaries, you see here the salaries prices, the salary ranges, we would extract some information which would analyze that column. So example, here we can see on the right some things we could extract. And we're gonna go through certain techniques you can use in your own data analysis. So technique number one in univariate analysis is something we already did today, and that is dealing with missing values. So for example, determining how many missing values you have. But sometimes it's not so obvious. Look at this example. Here we have a list of job positions, data scientist, but here we also have a variable called not known. And I never heard the job position which is called not known. So it's obviously referring to that the data about this job description is missing. So in this case, we could inference from this column that there are 3 missing values. Technique 2 is determining the distribution of your data. So with your data, we want to describe some basic statistical functions. And from this column, we could extract maybe the max, the median, the mean, the minimum, and standard deviation. So before we do this, let me show you how we can do this in pandas. Let's do some univariate analysis. So let's go to the final cells we have here, and let's click it. And we will first open, for now, the univariate analysis. So we click on that. And one way to do quickly univariate analysis in pandas is using a function called describe. So if you would like to describe the following column, let's say age, we would write df.age which means I want the column age, and then write dot describe. And if I run this, you will see all general statistics about this column. So we can see here there are 30,000 values. We have the mean, the average of 38. So the average person in our data set is 38. We have a standard deviation of 13. We have a minimum of 17 and a maximum of 90. So there's other ways to do this. There are more commands. So let's say we maybe want to calculate the median or other functions. Well, this is quite simple. Let's take another column. Let's say the hours per week. So to get the column, we will write df underscore hours per week. As you can see here, Google Collaboratories recommend me the command. And then we write again describe. So we can see here that the average person works 40.93 hours. Now, most likely that's nobody works half an hour. Sorry, 0.9 hours. So we could maybe take the median. Maybe that will tell us a better number. So we can write df.hours per week as previously, and then write dot median. And what happened here? Interesting. Live, first time we got errors live. Okay, so hours per week. Okay, I misspelled maybe hours per week. That's what happened. So we can. So here we want the median instead of describing the data, and we can see here the median is 40. All of these functions you can see here all of these script functions can be accessed exactly like this. So if I want just the median, the function would be then dot median. So mean. If I want the average, I would like the mean. I would write dot mean, and this would return the mean. What if I want the max? Well, you guessed it. It's dot max. So we write it here, hours per week, dot max. What about the minimum? Well, you guessed it, df hours per week dot min. Hours per week. So now with this new gain knowledge, it is time for a quiz. And the quiz is, what is the difference between mean and median on capital gain? So capital gain is the column. So it's written so if you want to access it, it's capital underscore gain. And I want you to calculate the difference between the mean and median. You know, this is a throwback to what we looked at last week, Bogdan, right?
Yes, of course. And overall, that's why we actually talked about statistic, because either explorative data analysis is 80% statistic.
So we're gonna start now. For now we're gonna give less and less time, except for some some other reason. But now we have exactly 45 seconds. Starting now. Okay, time's up. Let's see how well you did, guys. So don't forget to join AHA Slides to vote. The website is ahaslides.com/week2. Okay, we're gonna start the quiz right now. Let's see how well you answered this question. So if you know the basic of Pythons, you manage to do some basic operations. I think this was very easy for you guys. So let's see how well you performed. And time's up. Let's see how well you did, guys. And almost everybody got it right. That's very, very good. Okay, so for those two, or the people who didn't have time to finish the question, it's quite simple. It's df.capital.mean minus df capital. Oh, and I misspelled here capital. Capital underscore gain dot median. And this would return exactly 1092. Okay. But numbers are quite easy, right? If you want to extract basic statistics from numbers, it's like, okay, mean, median, min, max. What about this example? Here we have job positions. We have 3 data scientists and 3 potato farmers. What is the mean of this table? Is it farmer scientist? Is it maybe potato scientist? It's not quite obvious, right? So what you would do with such data, you would extract other type of features. For example, maybe what are the unique values, right? If it's nominal data, you could extract like here in this particular column, we have the data scientist, we have the data engineer, and the potato scientist. And to do this in pandas, there's a command called unique. So we're gonna do this now on work classes. So we have here the question, how many unique work classes we have. We would write df dot work class, because work class is the column we want to access, and then dot unique. And if we run this, it will write all unique values in that column. Very nifty. Okay, what other type of features you can, what other type of ways can you describe your data? Well, maybe the number of unique values, right? So if maybe I have a lot of unique values and it's very hard to count them, maybe is there a way to automatically calculate that? And in this case, pandas got you covered, because there's a command very similar to this.
You just need to add one letter.
One letter. With pandas, a lot of magical stuff can happen with just one single letter. And in this case, the magical letter is N, which stands for number of uniques. So if you run this, we can see we've got 7. But in this case, the question was, how many different type of educations are there? Well, then we write df.education. And we would see we get 16. Okay. Now, this is very similar to value count, and that can be also used. So, for example, here we have, if we take the value count, this would be like some combination of both, right? How often a certain value appear. And now we would have a quiz. And I want you to tell me how many people are divorced. And I give you in this data set. Not, I hope you guys all have happy relationships. I hope you're not in this particular data set. I hope you're all happily married or happily single or happily divorced, whatever fits you. So yeah, you have exactly 45 seconds to answer this question. Okay, so there's 20 seconds left, but those will be run on the quiz. So we're gonna start the quiz a bit earlier, right now. So the question was, how many people are divorced? And time's up. And there's a big conflict in answers, but mostly most people got it right. So the most easiest way to calculate this is by writing df. So there's a big challenge here, because I guess this could have been maybe a tricky for some people. But first we have to understand where is this where do we find the more divorced people. So if you remember, it is in column Marshall status. Now if you didn't know this, you could write always df columns to get all the columns names, and after that you could write value count, and value count would give you exactly every unique value and how often it occurs. So in this case, we care about divorced people, and therefore 4,250 people. So, and tip next time, always write, for example, df columns or df head, maybe to see what, based on the values, what column you may need to answer the question. Okay. Let's look about again to the leaderboard, how we're going, looking. And Max, again, out of nowhere, trying to back to back. But we have new contenders like the D, Sebi, Melissa, Bernard, Libby, and Lucas. Okay. But close, very close. They're just difference of 10 to 20 points max. So very interesting.
Exactly. It's like who types the answer faster. All those people got it correctly. So it's not even
a fair competition. It's about who clicks the fastest nowadays. Yeah.
Yes. Well, who has better internet connection?
Okay. Technique 3 we can use in univariate analysis is histograms. And histograms are a way to visualize your data. So you might see saw these in the first week where we plot a lot of histograms. And yeah, what you see basically is on the x-axis the values, and on the y-axis how often it occurs. And to do this in pandas, it's again one word command. So let's say we want to have the histogram of age. Well, we will write df.age, and the magic command is hist, which stands for histogram. And this will exactly give you a plot of a histogram, which you can then observe. And we can see here that we don't have any information for maybe people under 18. And this makes sense because they are not part of the working class. And then we can see here a nice long tail until 90. Okay. Technique number 4. Histogram plots are only relevant for numerical data. But again, let's say we have job positions. What do we do this? Well, one way to visualize this is a count plot. And the count plot is very similar to value counts, but you visualize those values, where on the x-axis you have your unique values, and on the y-axis you have the number of occurrences of that particular data. And we're going to show you how to do this on pandas. So Bogdan, how should I write this? How do we write a count plot?
So that's very easy. With pandas, everything easy and in one line. So first of all, we need to get a value count for what we want to plot.
Okay.
And then with that, we just say plot. and we need to specify in what format we want it. We want it to look like a bar chart, and for that we just say the kind equals bar, because we want a bar chart.
Okay. And if you would run this, we would exactly get the Marshall status of in a bar chart format. As you can see, most people are married, and then followed by never married people. Okay. So these are very nice ways to visualize it. And the final technique of univariate analysis we're going to teach you today is technique number 5, identifying extreme points. So some data points just stick out. So in this column, we have some salaries, and we can see everything ranges around 60,000, 70,000 euros, except one particular number, exactly this one, 500,000 euros. So the median of the salary is 74,000 euros. 500,000 euros is way over the median. It's an extreme point. And the way you can identify these extreme points is with techniques we previously used. We can use, for example, a histogram plot, for example, that can help us identify. So in this case, we plotted all values in a histogram plot, and we can see our data point all the way on the end there. Okay, but this doesn't answer the question. Why is the salary so high? And it's normally, most of the time, you will, in your real life job, you will see that most questions cannot be answered with only one variable. But it's a good way to get some hypothesis, right? Some things you would dig deeper later. And for this, we will find a way to find these extreme points very quickly. Oopsie. Okay, the slides reset. Technical break for 20 seconds. I seem the reset has reset themselves. Don't worry. So
Please stand by.
So in the end, what we would do to solve this problem is something called bivariate analysis, where if I cannot answer my question with one feature, maybe with two. So let's take one more column. We have the salary and we have the job position. And we can see here, well, data scientist, 70,000 euros, 74,000, data engineer, data analysis. And oh, bam. The CAO is making 500,000 euros. Well, then this explains more why the number is so high. But in data science, you cannot look at every single line of data. Especially in our data set, we have 30,000 columns, 30,000 rows. And in your work, you most likely won't have less than that. Most time, you will work maybe with 10,000, million, or maybe even 10 of millions of data entries. And you need to find this in a more automated way. Look at this example. Find me the CEO. Where is he? Can you find him? Did you find him? It's exactly here. So you see, it's very time consuming to actually compare directly two columns. And this leads us to the next technique, number 6, comparing statistics. And we can use all the first technique from univariate analysis, which is basically extracting statistics features and compare them with other columns. So, for example, we can group our salaries statistics about the max and median, and from every job position, and we can actually find more meaningful explanations. We can see, okay, the average salary for a data scientist around 72,000, but the average salary of a CEO is 500,000. Therefore, making the number not so crazy. And I think it's a good time to show you how you can do this in Pandas. And we can now finally open the final Pandora box, which is the bivariate analysis. So for the first question, we're going to do this together. So, I'm going to show you the magic of pandas of making two solutions. So first question we have here is, how many salespersons make a capital gain of over $80,000? Now, Bogdan, can you tell me one solution we could do?
So as before, we already saw that you can start with writing a query. DF capital gain bigger than 80,000.
Okay.
And then we can. So we are interested in occupation and the amount of those occupation. So we can do occupation dot value counts.
So first we write occupation, and here we can see all the occupation with the people who get capital gain of 8,000, and then you set value counts, right?
Yeah.
Okay. Good. And here we can see we have got 24 salespeople who get a capital gain of over 80,000. The second solution is you can do multiple queries in one. You can stack queries together. So we will do the following: we write df, and then we write after our square brackets round brackets, and we'll show you the minute why in a minute why. So here first I want a person who's a salesman. So we write dot occupation equal sales, and then I write an ampersand. And then my second question is, well, I want a salesman who makes more than $80,000. So I write df capital gain, as we previously learned, bigger than 80,000. And if you run this, we will get all that data, but we don't want all the data. We want only the shape, because this will. So in this case, if I write that shape, we will see we get 24 people. So this is the magic of pandas. There's no one way to do this, right?
Okay. Well, with experience, you will learn what is fast, what is slower. You will find what is the best way to deal with.
But for now, we will have a quiz. So with your new gained knowledge, you have to answer the question: how many rows have a capital loss and capital gain bigger than 0? Oh, we have the answer written there.
Please write the code and just don't use the answer that is provided on slides.
Yes, please calculate it and write your calculate by yourself, and don't take this answer. So you will have now, starting from now, 45 seconds. Okay, time to put your numbers in. Okay, 3, 2, 1, and let's see what you have answered. And some of them fell for a trap.
Somebody want to take easy way. Well, no, there's no easy way in data science. You have to check the stuff. Don't trust.
Yeah, always answer your questions with data. Never answer them with what people tell you.
And with feelings. There's no feelings in this data.
So the answer was df.capital gain bigger than 0, ampersand data frame capital loss bigger than 0. And if you want to take the shape of it, we will see it's 0. So good luck everybody who managed to got the correct answer. Okay. So this is interesting because that means that there's no way that you can have a capital gain and a capital loss at the same time, which makes sense, right? So what we're going to do then is create a new feature, a new column. And we're going to show you how you can create a new column where you can combine capital loss and capital gain into one. So if capital gain goes up, capital loss is 0. So we can write the following. We write a new feature like this. We write df, and here you give the name of your new feature, which in our case we will call it capital. And then we will say equal to df capital gain minus df capital loss. And this is how you can create new features. So instead of overwriting your df, you create a new df with a new column name. So this is how you write it. And if you run this, we would have this new generated feature. So let's say I want to calculate the mean of this. Let's see how it looks. Well, I write df.capital and then .mean. So you see you can already access your variable immediately after you define it. We can also calculate the median. So df capital .median. Okay. So with this new feature, which we generated, it's time for a quiz. Oops. Yep. So, okay, everything is fine. This is just the previous question. You don't need to answer it. It was already answered. But for those who maybe didn't manage to get in your answer, now you can actually do it. But for now, this will be fixed. Now, the next quiz is how many people have a capital of 0? So that's the question. And you will have exactly 45 seconds for that. And it will start right now. Okay, the quiz will start right now. So put your answer in. And let's see. So how many people have a capital of 0? Okay, thumbs up. Let's see how well you did. And most people got it right. So the answer to this quiz was df, a query, so df capital equals 0. And if I write that shape, I would get exactly 26,219 people. So very good, everybody. Now, what if let's ask another question. And what is the percentage of people which make capital gain of over $10,000? for this, we will do two things. If we want to calculate the percentage, aka the ratio, we would need two values. We need first the capital gained people, so how many people gained that so much capital over 10,000, and we need the total amount of people. And then we would divide them to get the ratio. So let's get first the total amount of people, and that is, you write total. Let's define a new variable where we save them. So total people count. And this is equal to data frame shape 0. How do we get the capital gain count people, Bogdan?
We need to use, I believe, count command, if I'm not mistaken.
So we would write df capital bigger than 10,000, and then we will write shape 0 again. And this will give us the row, and the this would give us the amount of people we will get which have over than 10,000. So we will run these two line of codes, and to get the ratio, we just write capital gain count divided by the total amount of people. So total people count. And here we can see that 2.4% of the people actually make a capital gain over 10,000. That's very low. The top 1% of the people, basically.
Yeah, that's unfortunate.
But now for again a new quiz. And this time the question is, what is the occupation of the biggest capital loss? So I want you to find the occupation of the person who has the biggest capital loss. And yeah, you have 45 seconds. One tip, maybe you would need to use min or max. I don't know. So your timer starts right now, and the answer to that question might surprise you. Okay, time to put your numbers in the quiz. And let's see how well you're doing. And hopefully, if you're ever experiencing huge capital losses, please don't react as these people on this GIF. Okay, let's see. So we have very low numbers. So I guess that was a bit more harder. And yeah, two people got it right. So it's actual executive managers. Shocking, right?
Well, no, I would say it's not shocking. It's more intuitive, because executives are usually have more capital than other people, and more you have, more you lose. Because if you have nothing, you will never lose. There was stream was down for a few seconds, I believe.
Okay. But everything should be up again, no problem. So
yeah, so now it's running. It was really short. That's why I was confused.
Okay. So the solution to this is df log df cap. So the query we want to do is we want to get those people who have a capital gain of minimum. So that's df dot capital equal. If I can manage to write capital, that would be great, won't I? And equal to capital.min. So that was the trick. So you want to get one. That's how you would get this. And if you want to then get the occupation, then you would, maybe one way to write this is dot occupation in the end. And here we see executive manager. Okay. let's do something more interesting. But let's first calculate the ratio between people who learn less than 50k and more than 50k. What do you think is the ratio, Bogdan, while I'm writing this?
Well, I hope 50-50, but my feeling is that there is much less people making more than 50k.
So the way we do this, we would calculate the value counts. And one cool trick is you can actually make operations in the line. So if I want to create the ratio, I could divide this by the total amount of people. So I would write df.shape 0. And this should work. And we can see that 75% of the people actually don't earn more than 50k. So only 24.9 people, actually earn. So now it's time for double trouble, actually. So you thought one quiz was hard? Well, guess what? We're gonna do 2 quizzes at the same time. So the first question: how many people with an income more than 50k have a capital loss? And after you answer that question, you'd have to tell me how many divorced people with an income of over 50k and have a capital gain. So first is capital loss, then capital gain. Be very careful on the question. Okay? You see here, capital loss, capital gain. You have been warned. For this, we will give you 2 minutes. And we wish you now good luck. Okay, time's up. And before we're gonna do the quiz, I want to remind you the current leaderboard situation. We've got actually someone beating actually Max for the first time. So we've got Libby on first place, followed by Max, the D, Sebi, Benhard, Arno, and Antti. And yeah, it's ready now. Let's put those answers on the quiz. So everybody get in on AHA slides, and it's time to show your answers. So let's see how you did. So for the first question was, how many people with an income of over 50k have a capital loss? So capital loss. Let's see how well you did. Three, 2, 1. Okay, time's up. And yeah, most people got it right, and some people had hard time with this. So, but because this is double trouble question time, let's see how well you answered the second question. So, this was very similar, but with a small twist. How many divorced people with an income of over 50K have a capital gain? So let's see how well you did this time. Okay, so time's up, and let's see how well. And yeah, most people got it right, but in case you had a hard time, let's go through the solution. So there are multiple ways to do this, but due to time constraint, we'll show you just one for now. And so the first question, how many people with income of over 50K have a capital loss? You do a stack query. So first we say income bigger equal bigger 50K, and ampersand, because we have a stack query where the capital loss is smaller than 0. And if we would get the shape of it, we would see that 738 people have a capital loss. Now for the second question, you would do the same. You could write capital gain here. You can copy it previously, and you can do one more ampersand here, and write here df marital status equals divorce. So in pandas, you can actually stack as many queries you want into one line, and this is one cool way to solve it. And therefore 128.6. Okay. So two more techniques. The one technique is scatter plot, which is a great way to visualize two continuous variables. So here we can see we have the salary and age. A scatter plot is just visualizing them in 2 dimensions, where every point is where the x-axis is the first variable and the y-axis is the second variable. And in pandas, is magical. You can do this in one line of code. So to do a scatter plot in pandas, you would do the following. You write df plot dot scatter, and if we want to get the age and the capital, we write age and then followed by capital. And if you run this, we will get this plot. Bogdan, I don't know, this looks weird.
No, that's not very usable, and no knowledge we can get from this. And that's what usually happens with real world data. It's not ready to use, and we would have to do some transformation on it, but we will probably talk about that in next lessons, because we will explore a nice ways to represent data, nice plotting techniques.
So this is unreadable, and one way of the way we gonna do this next time is the technique called averaging, and this will actually help a lot. But for now, if you just want to scatter some two data, you can write this command, plot.scatter. Okay, and for the final technique of for bivariate analysis, it's a linear correlation. And linear correlation refers to the straight line relationship between two variables. So if we see the first image, we can see a positive correlation, which means all the points follow a upward trend. Negative correlation, you guessed it, is downward trend. And no correlation at all is there not following any particular trend. So if I have a perfect correlation, then all my data points, if I get the correlation score of 1, my data will be linearly correlated exactly like the first example. They perfectly build the perfect line. However, real life data is not like that. So it's most likely something like this, where it's a bit more scattered. And therefore, the more scattered it is, the lower the correlation becomes. And you can see here, then here, when it's a big blob of mess, it's 0. And then it goes, then if in the negative direction, you get a negative correlation. Okay, so what is this number? So what can I do with this? Well, before I can show you what you can do with this number, let's see how we can write this in pandas. So Bogdan, how would you write this?
Well, as everything in pandas, it's one line. It's a df.correlation.
So df.core.
.core, yes.
And what are we seeing here, Bogdan?
Well, that's a correlation matrix, and on diagonal always 1, because values are correlated with themselves exactly. And yeah, so from this plot we don't see any high correlation, only between capital gain and capital, but it's because we used capital gain to create capital. So
yes,
that's very same values.
Okay, so okay, good. 1 minus 1 0. Okay, what does help me? Well, linear correlation. So correlation general measures the extent to which your variables depend on each other and predict one another. So we as Bogdan said, the capital is based on the capital gain and capital loss, so therefore they're correlated, right? They depend on those variables. But we're more interested when we're predicting it. So if you remember the example from last week where we used the number of rooms to predict the price, then the correlation should be high if we would get good predictions. So let's go through some examples, some correlations. Rainfall is positively correlated with the amount of vegetation. If it never rains, there's no vegetation. As simple as that. Another one is pollen count is positively correlated with bee activity. And this, I have a question to you. Is bee activity the cause of pollen count? So pollen count is positively correlated with bee activity. Question is if bee activity causes the pollen count. So get up on AHA Slides. It's ahaslides.com/week2, and let's see how well you answer this question.
And if I'm not mistaken, it's the last quiz for today.
So it's the last quiz of today. So let's be ready with your fingers, and let's see how well you're gonna do today. And we're gonna start in 3, 2, 1, and I think we are ready. Let's go. And let's see how people did for the final quiz of today. And wow, that's amazing. A perfect 50-50 split. Wow.
That's
so
interesting.
Very interesting. Unfortunately, research actually showed that bee activity is the main cause of pollen count. So that's why it's most likely, because it's not, the answer is not it's not definitely yes, because it's not the main, the only cause, but because it's the main one, it's most likely the cause of pollen count. Okay, let's see the leaderboard. And our first place is Lebi with 1,133 points. Very close, followed up by Sebi, Max, which unfortunately he got dethroned today, the D, Robert, Bernhard, and Antti. So great guys. All the points will be saved. So there's still more quizzes to do, more assignments to do, and also a great final project. So let's see some fun examples. Did you know that Japanese passenger cars sold in the US correlates with suicides by crashing of motor vehicles. Huh. What else correlates? You know this guy, Nicolas Cage? Well, Nicolas Cage might have something to do with pools. Water pools, which you swim. What do they have in common? Well, the number of people who drown by falling into a pool correlates with films Nicolas Cage appears in. So I guess if you watch Nicolas Cage, maybe you will die from drowning. Who knows? And finally, did you know that Internet Explorer correlates with murder rates in the US? So I don't know, but that makes sense for me, right? People dying from Internet Explorer is not shocking for me. What about you? What do you think about this?
Yes, you know that the internet ping kill more people than alcohol. I suggest, I have no numbers to back it up, but the ping and bad internet connection sucks, and it can make you very angry, and people kill when they are angry.
So correlation does not imply causation, and just because something is correlated, it is not the main cause. Correlation can happen in random in nature, so you have to be very cautious when you say this caused that. And this we're going to explore more actually on week 4 when you talk about machine learning algorithms. So we're almost done. So let's talk about assignments. First assignment, we will give you a new data set to explore. So we will give you the solution from today, so you can explore at home. And you can also use the new data set to answer the new questions, which you will have to answer in your assignment. So there will be a quiz, and same as today's quizzes, there will be questions. We don't want the code, we just answer.
Yeah. Okay. And if you have some problems, you can always send us mail, ask, and we will be very glad to help you.
Yes, so please send your questions. We will have a Q&A session right now, so you can ask now. But in general, if you can write us, we will answer all of your questions. And if there are a lot of questions, then we will maybe organize a Q&A session. So don't be shy, write us. We are ready for you. Okay, some information. Yes,
I just wanted to say that we really appreciate you guys sticking with us for already nearly 3 hours. And we are now, Adrian will give you some nice info. And I hope you will show us these good examples that you had prepared, so people can just relax and see professional working.
Yes, but I think people have some questions, and after that, I think it's a good time to show a demonstration. Yeah. What do you think?
Yeah. That's so. For the final demonstration, you will just see what you will be able to do when you master everything.
So after the Q&A session, if you stay along, we're gonna answer the final question on the notebook. But until then, let's give you some information. The video of today, so the stream, will be uploaded on YouTube. Please check the newsletter.
And please like and subscribe on YouTube.
Like and subscribe. Hit this
notification button.
The slides from this week and from last week will be also uploaded. So for those people who want the slides, we will finally give you the slides. The assignments will be provided also via newsletter. So if you try to register to the newsletter and it didn't work, the main reason is you have to disable your ad blocker. A lot of people have experienced problems trying to register. Just disable your ad blocker. I don't know why, but then it works. So if you didn't, you need to register, because only there you get the assignment. You also get the current notebook of today, and also the final demonstration. So in the final demonstration, please don't write anything. You will also get it there. Anything to add, Bogdan, before we go to Q&A?
No, just tell other people. Remember, like, more people you invite, more.
And you can get those 10 points as we promised. Okay, let's answer some questions.
Okay.
So on Eha, if you want to join and ask questions, please go on ahaslides.com/week2 and you can answer your questions there.
Sure.
So let's go and ask the first question. OSDev asked, it would be good to provide quick references for used functions because it is hard to remember syntax when shortly shown.
Yeah, good point. We will include that in future lectures.
Okay, next question. Rick Jarzy asked, is it allowed to ask more general questions about pandas too?
No, I'm joking. Of course you can.
Please
Ask, and
don't be ashamed.
yes, and ask if you practice it. You can send us email with examples and the problems you have, and we will help you out. Don't worry. We are glad to help. And our contacts are website and I think in description in newsletter. So
yeah, if you respond to the newsletter, it's fine. We will also provide the emails on the newsletter for today. So I mean, not today, but tomorrow you will get a newsletter with our emails. Dr. Evil asked, this was I think a bit older ago. When I run dfh describe, I get this thing. Do I have old pandas package? Yes, most likely you have this. So if you get different results, what we did with the same code, this is because you have some outdated library. Google Colab has always the latest version. Dr. Evil asked again some error. Again, Dr. Evil, we will provide you the final the complete solution. See if it still works. If it didn't work, then most likely your packages are outdated. Okay, Dr. Evil gave up after seeing like he asked for the video. So yes, Dr. Evil, don't worry. Maybe you're not here, but yes, you will have the video.
Yeah. And don't be discouraged if you cannot follow code live. We know it's tough, but we try our best to give as much explanation as we think is enough. But don't be discouraged with it. You always can go back, check the notebooks, and try something.
And this is a perfect segue to the last question. Amar, will your notebooks file be available afterwards? Yes, they will. Okay, so I guess now it's time for some demonstration. Let's show how experts get their hands dirty.
Yeah, so just sit and follow Adrian and just relax. So, and don't worry if you don't understand what he's writing. It just showcase how it can be done.
So Bogdan, I think we have this question here. And this question is, do men make more money than women? So what do you think is, what should we do as first? What do you think is the best thing we should do first to answer this question?
Yeah, we should, you should do it because
okay,
people want to see you working, not talking to me.
Okay, so first I'm gonna group by sex. So group by basically groups the data for me by a certain column. So if I write group by.mean, it will group the average based on a certain value. So here I have two sexes, male and female, and here I can see the average age of male, average age from female. But I'm not interested about only sex. I'm interested also in income. So first, I can do a double indexed group by, which is sex and income. And I'm going to get the count. So the count will give me the number of people with a certain sex and their income. So here I can see for female with under $50,000, I get we have around 8,600 entries. So this is interesting. We don't need all of this because they're all same numbers because we're just counting the number of occurrences. So here I will just take, let's say, capital. It doesn't matter which column I would take. And okay, this case looks very nice. So we have the numbers as quite to determine, if men or women make more money because the number of people we is different. So I think I should maybe calculate the ratio between those values. So I will save this in a variable called sex income. And I will then calculate the ratio. So to do this, I have to do it twice, once for male and one for female. So I guess if I write sex male, I will get the incomes from male. And if I want to get the ratio, we would use a technique what we previously used is by getting the total amount of males. So in this case, I can use the same column and just write sum. And what this does is that I'm counting basically each variable here is divided by the total sum of these two variables. So if I run this, I will get the ratio. So we can do the same for male and female. And we can see here 68% made less than 50K. And okay, these numbers are interesting. So we can see that only 10% of women make more than 50K, where in males 31% of males make over 50K. So there's a big difference here, a big gap. So I think an interesting question would be to ask, is this gap like all the time? Is it like is it in all occupations the same? And for this, we can explore this. So the question would be, do men make more money in same occupations? So to really get a clear answer for this question. And for this, we need to do something similar as before. But we also have to take the occupation into account. So I will write the following. I write df group by. And here I will group it by occupation, sex, and income. And then I will get one of the, I will write count. And I will get one of the columns. Because as we saw before, they're all the same. It's just the amount of rows. And it doesn't matter which one you pick. So if I run this, I would get all the jobs on the left. Then in the middle, we've got the sex. And finally, we get the income. Okay, so this looks fine. But again, these are numbers. We need some ratios. It's a bit confusing. So for this, I think I'm going to write a function which automatically calls me the ratio. We have like so many indexes. So we're going to write df temp, and I will save all these values in a variable. And I will go through every index. So occupation, sex, and income. So for this, I will write for first in df occupation dot unique, and this will give me all the unique values, and I would iterate for all unique values. So this will give me all these occupations. Then I will need to do another for loop second, which goes through the second index, so sex. So in this case, df sex dot unique, but I have to not take all sexes. I need to take a particular sex in a particular occupation. Something like this. And finally, we have to do the same check as we did before by dividing it by the sum. So here I would write df temp. I like to use log. It's better for using when you have multiple indexes. and I write here first and second, which says I want to go through the first one, then from in the second indentation I go second, and this here says all the values, remaining values. So this would be the income bigger than 50 or lower than 50. In this one we divide equal, so this is just division with the same thing and the sum of it. So lock first, second, and sum. And I think this code should work if I wrote it correct, I hope. And oh yeah, it's first here. This should be fine, and I think this works. Yeah. So if we look one more time on our new column, on our new data frame, we would see here a nice image. And I think there's too much information. I could maybe just display those with over 50k, because I don't think we need those values under k, right, Bogdan?
Yeah, because we are interested in high salaries.
Okay, so first we've got clerical. So their men are dominating.
Yeah.
Armed forces. This is only male job. But more shopping, so it seems like overall it's like in every case men are dominating. But here is shocking. This one, executive managerial.
Manager.
Yeah.
Executive manager.
Yes, thank you. You can see here males have 58% of them get 50k, and only 24% of female. That's a huge gap.
So it means that there is 75% of executive managers female that get less than 50,000.
Exactly. Wow. Okay. I want to answer one more question, and then I think I'm done for today. And the question is, do men make more money over the age? Because I want to see if, like in the beginning, maybe the difference is not so big, and as they climb up the corporate ladder, male will get more money than females. This is just a hypothesis. Maybe it's wrong, maybe it's not. So I think we can explore that before we go. So for this, I need everything what I used before. I'm gonna copy it. And the only difference here is I don't care about occupation, I care about age. So I will replace everything with age here. And again, why I'm doing this, because I also want the ratio. And if you look at this, we get all those values. Now, it's a bit unreadable. I think a good way to see this is making a plot. So I will do a plot. One for female and one for male. So, like following. And we're already interested about the people who are doing over 50k. And we do one for male, one for female. We can stack them together. The beauty thing about plots is like you can do two of them at the same time, and it looks something like this. And wow. Any thoughts on this image, Bogdan?
So that's what we see. That's what is called gender pay gap. We see that males make more money.
And it seems like it's meeting slowly together near the after 70. It seems like it's closing.
After retirement age.
After retirement age, it doesn't really matter at that point. Yeah. Okay.
So that's all for today.
Yeah, I hope you enjoyed yourself. Yeah. It was a very long day, and thank you for everyone who stick to the end. And we will send you, as mentioned, the videos, the assignments, the notebooks, everything. And I think thank you for sticking to the end. Really, that's amazing for all of you that really stick to the end. Hopefully you learned something today, and don't be discouraged, as Bogdan said. Any last words?
No, I hope not last words. Hopefully we'll meet last week.
I mean, last words for today, but yeah, sure. Okay, guys.
Any questions? Send us mails.
Yes, send us mails. And okay. See you then next time.
Yeah. Ciao.